All right. Well, thanks for the introduction, Kelly. It's a pleasure to be here for LINAC to be sponsoring the Farming Robotics Challenge again for the second year now for us. And we're excited to be a part of some of your guys' projects and to see what you guys come up with. So here at LINAC, we're a manufacturer of industrial linear actuators. They can be used in a whole host of different industries, and we'll kind of get into some of their applications and how they can help out in some of your projects later on. My name's Casey. I work as a sales engineer alongside Eric, and we're going to be available throughout the competition to help out with any technical problems that come up or just logistics involved with getting you guys your actuators. So before we get into the technical details, I just want to give you guys a brief overview of LINAC, kind of who we are and what we do. So LINAC was actually it's a family company, and it was started out in Denmark, which is where we have our global headquarters. Now, since its beginning, we've started to expand throughout the rest of the world, and we currently have 6 factories, one of which is here in the US. It's out in Louisville, Kentucky, which is where Eric is stationed out of. We have R&D as well in the US. And just as a company, we're continuously growing, currently at 2,400 plus employees and over 12,000 customers. As I mentioned, in the US, we do have our US global headquarters in Louisville, Kentucky. On site, we do have manufacturing of the LA36. That's one of our more popular industrial actuators. We do have application engineering support as well.
Awesome.
I'll pass it over to Eric.
Yeah, thank you so much, Casey. So just a really quick background on what our linear actuators are and why we think they're important. As vehicles continue to electrify, we're seeing more and more opportunities to replace hydraulics in small applications. When I say small, I mean less than 20,000 newtons. And the basics of how our linear actuator works is pretty simple, pretty straightforward. We take a DC electric motor, there's a gear train, and that provides power to an acme or a ball screw, which will then push a rod forward and allow you to move any linear direction. We're seeing a lot of growth in the ag application arena, as Casey mentioned, but we also do extensive work in the medical field and in home and office furniture as well. My particular group focuses on ag, and I particularly work with a lot of the big guys in terms of harvesting equipment. I think something that we've brought as unique to our product over the years, they've moved away from being a classic actuator where you turn a motor on and off, and they've become fairly complicated and good at doing tasks that are above and beyond what we might have been able to do 15 years ago. A lot of that has to do with integrating CAN bus into our products, which allows our users to control current feedback, position, recovery, messaging, all things that allow the end user to more effectively operate their equipment remotely. And this includes also things like internal H bridges to control motor feedback and also for safety purposes. Yeah, one of the advantages and things that we like about this particular product line with the Acme screw is that you get a natural brake effect, and when you're stationary, it stays stationary.
Excellent.
We'll highlight the 2 products that we're bringing to the table today. The information on the left, the little guy, our LA14 product, has all of the CAN bus features of our big actuator, but at a much smaller package and with a much smaller load rating, only up to 300 newtons and 130 millimeters, works off of a 12-volt motor and can accomplish 40 millimeters per second as a max speed. That's the guy pictured on top. Our larger actuator, the LA36, is our most popular in our large agricultural applications. has much higher load capacity at 4,500 newtons. This particular example will go 300 millimeters of stroke. It operates at 48 volts and has a 21 millimeter per second maximum speed rating. One of the things that I think we bring to the table that we love is the introduction of CAN, being able to communicate this way. Of course, you can run these actuators as strictly a manual in and out by providing power on the brown and blue cables, and then your signals on the red and black. But by introducing CAN, it does unlock a lot of features for positioning and feedback control that our customers find extremely useful. Some of the things that you're going to get from us, obviously, data sheets, step files. We have our own manual on CAN bus specific to our product, which tells you all of the types of commands that the actuator can understand. The LA14 actuator is going to be able to ship earlier than the LA36s, sometime mid-November. The LA36s will be available to ship at the beginning of January. We have a total of 15 each for any teams to use, and they're available on a first come, first served basis. And for logistics purposes, we are extending these only to teams in North America. Really quick example. I'm sure you can tell by the color which customer this is, but this is basically a green tube unloading spout application, something we typically see great value for our product, right? This sits 20, 30 feet from the operator, 30 feet up in the air, not exactly the kind of place you want to get to when you're in the middle of a field. And so this actuator allows the operator to articulate the end of this grain tube as they're going without having to make any exits from the vehicle or do any manual work. And the next slide, what we're looking at, it's a little harder to see, but in the middle, that's our LA14 sitting horizontal fertilizer spreader application. It allows, again, for safety purposes, much easier to push a button and have the actuator do the dangerous work of adjusting position and gate openings around moving equipment. Another example of a fertilizer spreader and how the LA14 can be used to make the kind of adjustments that in the past would have done manually or with the help of hydraulics.
I also listed some other examples of usage for our actuators, and these are actually taken from the competition last year. So because these actuators work on the CAN platform, they're pretty easy to integrate with the rest of the Amiga platform. So you can see some creative ideas that previous teams have used with our actuators. So on the left here, University of Delaware use our actuator for a soil probe attachment. So really what's going on here is this Amiga platform will drive around and there's a little soil probe on the end of this actuator here. And the actuator will dip that soil probe into the soil at different locations to measure temperatures, water amount, key nutrients, and other factors like that. Carnegie Mellon also had a pretty creative application of our LA36 actuator. It's kind of hard to see, but it's right up here mounted above this auger. And within their application, they used the LA36 to drill these small holes in the soil. And they used a cobot arm to grab small trees to plant in those holes that were drilled by the LA36. So just a couple ideas to kind of get your minds running and different ways to integrate our product into different projects. And we wanted to list our contact information for all the participants in this competition. You can feel free to reach out to us with any questions. We're always happy to help out with logistic details or any technical details that might come up. I think that's all we have.
Can I ask you guys a few questions?
Yeah, sure. Please
Absolutely.
do.
So I'm a team. I'm interested. Is there a single person I reach out to, or either one of you? What's the process?
Yeah, I think it would be best to email myself at cmunch@linac-us.com, or you can
Okay.
give me a call. You can also CC Eric as well, just so that we both get the email. And yeah, we should be able to walk you through kind of the ordering process and how you get your actuators.
That's really great. I think it's really generous offer. So essentially, it sounds like you have 30 units that you're making an in-kind donation to the team so they can use in their projects. And I'll just add that both of the teams that you showed on the previous slide were winners last year. So that's kind of cool.
They were, yeah.
Yeah.
Really exciting to see.
The only other thing I would share, if anybody else doesn't have questions, we have posted up the Linac resources on our website. So I'm going to go ahead and share my screen real quick to show you guys where that is at. So if you want to navigate there, let's see. So it is just on our website on the resources tab. And if you scroll down through the information here, which if you haven't checked out this page, this is where we post a lot of great stuff. Your project proposal information, some various flyers, our webinar recordings. There's some Amiga information, and then here's the Linac info. So yeah, they provided us a lot of great files. So if you want to click on the different products, this is going to give you a zip file that contains all the models and data sheets to kind of you can look through for your projects. So just know that that is on our website and available to you guys. All right. Do you guys have any closing comments, or is that pretty much it from Linac?
That's all we've got. Thank you for your time.
Yeah,
Okay, no, thank you for joining. Yeah.
our pleasure.
Oh, here's one question before you hop off. Can you repeat
Yeah, no problem.
information about the stroke length?
Yeah, our larger actuator, I believe, is 300 millimeters, and the smaller actuator, Casey, is it 30 or
130, 130, I believe. Yeah. And again, this will all be in the technical documentation that's located on the website. It will go through the specs of the actuator. So if you have any questions about any of those technical specs, that's a good place to look for them.
Okay, the follow-up question is how fast can we adjust the position of the actuator?
Yeah.
Meaning,
So
go ahead, Casey.
yeah, I have the numbers up here. So the LA36, that's the larger actuator, and that's going to have a speed of 21 millimeters per second, so almost an inch per second. The LA14 is actually going to be a little bit quicker at 40 millimeters per second.
Right. Well, what is the frequency at which we can update the position?
In terms of sending CAN commands, it's going to be as quickly as you can send them. So you can set current limits, you can set position limits, you can set speed limits all over the CAN network.
Great. We'll give it 2 seconds. All right, we got it. Thanks.
Right.
So that's
All,
Dijon from UC Santa Cruz. So good
all
questions there,
great
Dijon.
questions, guys. Yeah.
Yeah, yeah, I appreciate it. Okay. Well, let's move on. Thank you, the whole Linac team, for joining the call and for being a great sponsor of the challenge. So all the teams out there, you guys have the information. Feel free to reach out to them if you're interested in adding this piece of gear to your project this year. So with that, we're going to move on. We're going to head over to Rich at All Tracks. So Rich, are you ready to go?
I sure am.
All right, take it away.
Okay. That's showing up pretty good.
Looks great.
Okay. I want to thank Kelly and Linac for for putting this on. This is our first time working with the FRC on this. Only found out about it a few weeks ago, and we decided this would be something that we would like to get involved in. My name is Richard. I'm the director of sales here at Alltrax. And for anybody who doesn't know, a motor controller is basically a dimmer switch and an amplifier put together to make a motor run. And a little bit about Alltrax. We were founded in 2001 here in Southern Oregon. It's a family-owned business. The owner is Damon Crockett. We started off doing motor controllers for golf cars because there was a need for performance upgrades, and there wasn't anything in the market. And that's where we really cut our teeth on motor controllers. Like I said, we started off in golf cars and have moved into all sorts of other industries, which we'll kind of just touch here real quick. Over the last 25 years, we've built over 250,000 controllers. We sell into about 24 different countries, and currently we have about 17 active OEMs that we sell our controllers into in different applications. We've got go-karts, we've got hydraulics, golf cars, all sorts of just nifty products and industries that our controllers go into. Our goal was to make the best motor controller on the market. Being biased, we think we hit that mark. And we wanted to create a flexible platform that would allow the controller to work on pretty much any application with really little to no modification. You just connect what you want, program it, and then it makes the wheels move. And the other thing that we really wanted to do was have world-class support and quality and prove that a U.S. manufacturer can compete with anybody. And all of our engineering is in-house. We manufacture everything in-house. Our support's in-house. And we all do that from our two facilities here just outside of Grants Pass, Oregon. So a couple things that we've done in the past, mostly golf cars, from basic bone stock ones to upgraded ones. For years and years and years, we were the go-to company for that. We still are, even though the competition's got a little fierce in the last couple of years. But we have branched out into other industries. We've done electric bikes, airplane. That really caused all sorts of issues when we got that picture. You can't quite see it, but the controller is mounted right behind the propeller. And we're the official NASCAR U Series controller manufacturer. They were planning to introduce it for next year, which is just their kind of development league. And I think they still have plans for that, but the tariff thing has been causing issues with them. But we're in lawn equipment, boats, go-karts, people movers, scale trains. So we've done all sorts of different applications, and now we're looking at moving into ag. We've got 2 ag customers that we've been working with, and we think joining FRC would be a good way to help further into that move into that industry. We've also had a lot of stuff in TVs and movies. Mythbusters used our stuff quite a bit. The Death Mower, if anybody's familiar with that, used 3 of our controllers. We're American Choppers, Colin Furs on YouTube, one of the big kind of science maker channels, has used our controllers a few times. We've been in commercials, movies in the past, for like the Italian Job. They created a whole bunch of electric minis with our controllers for a subway chase scene because they couldn't have gas cars. But really, at the end of the day, what we really like to do is go fast and do dumb things. And this is kind of where we are. We build our stuff robust to handle being submerged or popping a wheelie on a golf cart. And we really cut our teeth on really extreme environments. I wish I had a picture of it, but the first hybrid electric snowmobile on the big glacier, it's like the Jacobson Glacier in Greenland, where it's typically -40, was one of our controllers. So, we've been all over the place. Now we'll get into what we actually do. So, for this competition, we've got our AC controller, which is a three-phase AC controller that will do induction and PMAC motors. And if a motor is something else you need, we've got some 5.5 and 4.5 kilowatt induction motors. The combination of these two things will, just even one of them will move pretty much anything. If you need more, more power on wheels, on more wheels, we've got that ability also. So this is our AC1. Again, it's 24 to 72 volts. You can run it up to about 90, but don't run it any higher than that. 650 amps for 2 minutes and about 350 amps continuous when there's airflow. It uses an active cooling setup, so it does need a bit of airflow. But the controller is potted, so you don't have to worry about debris or water or chemicals getting into it. There's two available options. One has a 23 pin and a 35 pin amp seal connector. The big difference is whether or not the temp sensor and the motor sensors are built into the wire harness or separate. The 23 pin is the separate one. All the controllers use as my engineer just said, I spelled RTOS wrong. All the controllers use an ARM processor. We've got an RTOS on it, which allows us to do a lot of watchdog functions. So we can catch a lot of issues long before they happen. And depending on what the alarm is, we either go into a limp mode or shut down, and the controller will tell you what alarm it is. All the controllers have at least one CAN port. The 35 pin amp seal has two, and that one is isolated, if I remember right. One of them is isolated and one of them is not. I think the 35 pin one is the non-isolated one. We also use a USB port. That's how we program it, and a lot of other people program it. You can just use a printer cable and connect it to a computer to program the controller. There's also an optional Bluetooth module, so you can use your phone. So a couple things that we've got. Our controllers are capable of primary and secondary. The controllers themselves can do one primary and one secondary, so you can have four-wheel drive, tank steer, so you can have like a motor in the front and a motor in the back, and they can run. They communicate over CAN, and they share torque information, speed information. So you get so you have a really smooth drive on the system. You don't have to worry about the front and the back kind of fighting each other. We've really dialed in that ability for them to work together and operate at the same torque and RPM. If you're using an onboard control board that's handling all the communications, you can then use up to 8 controllers and motors as secondaries, and basically the primary would be your motherboard on your machine. So you can run up to 8 individual wheels or axles, whatever you need to do. All of our components are potted into urethane. So it allows, basically it's waterproof and environmental proof. You could take that sucker and chuck it in a pond as long, if your wires were long enough, and it would run all day long underwater in the nastiest pond. We've done all sorts of torture testing to it, and short of a bullet, really, it's not going to affect what it can do. It'll run underwater, run in ice, hot, dusty, you name it. And the big feature that we really like to push, it's customizable. You can go in and set how you want it to perform, down to pretty much the smallest detail, how you want it to run. And it's got profiles. It's got 3 profile settings on it. So you can have 3 different run modes. So you can have something like it's a little faster going to the field. And then once you're in the field, it clicks over to another profile. Um, the controller operates on CAN. We're in the process of getting J1939 going on it. Right now, we're running our all tracks CAN. So anybody that uses our stuff will provide you with the CAN messages, and then uh, once J1939 is fully implemented, we'll go ahead and just issue a software patch, and then you can use your standard J1939 commands. We've also got motors. Like I said, we've got a 4.5 and a 5.5 kilowatt. It's available with the 56C frame and the 7/8 keyed shaft. So it's anybody who uses something like a Mont Energy motor, same face, same shaft. Um, Max RPM is technically 13,000. If anybody needs to run it more than 10,000 on a farm, you're doing something wrong. But it is capable of out to 10 to 13,000 RPM. The 5.5 kilowatt will do 150 Newton meters at 1,000 RPM. So torque is not an issue with this motor. Again, it's got max 21 horsepower, and we'll do peak 50 kilowatts for about 5 seconds, and then do 4.5 or 5.5 pretty much continuously, S260. So for about 60 minutes, it'll run it at its rating. So you got a lot of runtime with a lot of power. Again, the programming, you can either do it by computer via USB, or you can use your phone and Bluetooth. The program is the same between both of them. So if you use one, you can easily switch to the other with almost no issue, because they're same. Everything's the same. Everything's laid out very similar. So that is what we do. We're planning. We haven't decided on how many kits we're going to offer up. It will be first come, first serve. We'll probably, I think, probably limit it to about 10 kits. So if you need to do multiples, you can do 2 or 3 of them. And again, they'll be first come, first serve. If you have any questions on specifications, wiring, all that kind of stuff, just feel free to reach out to me. My email is there on the screen. I will also get Kelly drawings and some specifications to put up on the website, so you can refer back to that website. For the people who come on later, feel free to swing by our website to see what we do. We're a fairly small company. There's about 25 of us here across 2 facilities. And my phone number is on the screen there. So if you have any questions, email, call, we'll give you a hand. If I can't do it, then our director of engineering he'll tell me the answer, and then I'll relay it to you. Any other question? Anybody have any questions or anything?
We'll give it a second. I don't see any in the chat just yet, Richard, but
Okay.
really great presentation. Looks like you guys have some fun on the side. I gotta say, those souped up golf carts. I want to get one of those for my neighborhood. That looks great. Yeah.
The one that's popping the wheelie will do 54 miles an hour, 52 miles an hour,
Oh my goodness. Yeah, that's wild.
and scrape the bumper. Yeah,
Yeah.
it's kind of silly, but for a high torque application like a ag robot, it really lends itself to um, being there without having to worry about, do I have enough power to make this thing move or move through the dirt.
Yeah. Okay. I just see a comment that came up here real quick. Question. Do you have controllers for BLDC motors?
Uh, Cody, we probably want to let Cody in, and he can probably answer that question better than I can.
So my name is Cody Renner. I'm director of engineering here at Ultrax. So no, we do not actually sport. If you truly mean a BLDC motor, no, we do not. However, in the industry, there's quite a bit of confusion where they consider induction, permanent magnet, and BLDC all as BLDC because they're technically all brushless. We do support the induction and the permanent magnet motors, but not the BLDCs. Or we also do not support the 3 Hall effect sensor outputs for the speed sensor.
Cool. Thank you, Cody. We'll see if there's a follow-up. Oh, no, thank you. So, all right. If anyone else has a question, now's the time. Otherwise, you have Richard's contact information there. I'll work with him to get some of the documents up on the website in the same section where you saw the LINAC info and the resources. And I'm curious to see, what the creative minds out there put these cool pieces of gear to work on. So yeah, thank you guys for joining the call today and supporting the competition. Really appreciate you doing this for the teams.